Hello, so in this video, I'm going to be going over solving equations by completing the square. First of all, recall that a perfect square trinomial is one that fits this form, and it can be easily factored into that. The goal with completing the square is to force one of the sides of the equation to be in this form. So, what do I mean by that? So let's say we have an equation that is x squared plus 10x plus 2 is equal to 5. We want this half of the equation to be in this form. So I can rewrite this as, first of all, I'm going to put the 2 over onto this side so that just the x's are over here, just so it's easier to look at. Minus 2, we have x squared plus 10x is equal to 3. So I want this side of the equation to fit this form. So what I'm going to do is I'm going to rewrite it again it's easier to see. Plus, we have to have a 2 here, so I'm going to have 2 times 2 times 5 gives me 10, so I'm going to put 5 here. And then we still have that x is equal to 3. So we can see that this is sort of starting to fit this form, right? So our a would be x, and that means our b would have to be 5. So I'm going to just sort of shove a b squared into there. So I can say x squared plus 2 times 5 times x. Then we need a b squared, so I'm going to say plus 25. But since I added 25, I need to also take away 25 so that the equation still works, right? So notice that I'm only adding 0, so I'm allowed to do that. So I'm going to get rid of this negative 25 from this side because that's not part of this equation. So I'm going to say x squared plus 2 times 5 times x plus 25. So I need to get rid of this negative 25, so I'm going to add 25 to both sides. And that would be equal to 28. So now we can see that this side of the equation fits this form perfectly. So I'm going to factor this out into x plus 5 squared, right? Because this is a perfect square trinomial now. And then we still have the 28 on this side. So this is in a form that is easier to solve because we can just take the square root of both sides. And then this gives us x plus 5 is equal to 28, the square root of 28. Then we could just subtract the 5. And that gives us x is equal to the square root of 28 minus 5. Just a note on this example, so you need to remember when you take the square root of both sides, this ends up being a plus or minus, just because when you take the square root of a positive number, you get a positive root and a negative root. So this ends up being a plus and minus, and this ends up being a plus and minus. Even if you've done this stuff a lot, you can still forget to do that, which I have. So I'm going to run through an example of this. So here we have 9x squared plus 12x minus 7 equals 0. I'm going to put this 12 on the other side. So we get 9x squared plus 12x is equal to 7. I'm going to rewrite this to be in the form of a perfect square trinomial. So I'm going to say 9x squared is the same as 3x squared, right? Because 3 squared is 9, x squared is x squared. This is going to be 2 times, so we know a perfect square trinomial needs to have the a and the b in it. So it needs to have this 3x in there. So what also needs to be in there to give us the 12x? Well, we already have the x. 2 times 3 is 6. So we need another 2 to give us 12, right? Because 2 times 3 times 2 gives us 12. So that makes our a this, right? And that forces our b to be 2. So b squared b squared is going to be 2 squared. So we get 4. And then to keep the balance, we have to subtract 4, right? Because we need this to be 0. Because we can only add 0. We can't change the meaning of the equation. And then 7 is still over here. So we don't need this 4 to fit the perfect square trinomial form. So I'm going to move that 4 over to here. So I'm going to get 3x squared plus 2 times 3x times 2 plus 4 is 2 squared, right? So I'm just going to write it like that so you can see that this is in fact a perfect square trinomial. I'm going to add this 4 to both sides. This 4. And that's going to be 7, 8, 9, 10, 11. So since this is a perfect square trinomial, we can write it in this form. 3x. So this would be our a. This would be our b squared. We still have the 11. So then we can just do the square root of both sides to get rid of that squared. So this gives us 3x plus 2 is equal to the square root of 11. Let's subtract this 2 from both sides, get rid of the 2. So we get 3x is equal to the square root of 11 minus 2. We need to get rid of this 3, so I'm going to divide out the 3. This gives us x is equal to this mess. Same note with this one. So when I take the square root of these two, since the square root of a number can be the positive or negative number, this ends up being plus or minus, and you get a plus or minus here. Don't forget to do that like I did. Now, just for fun, let's see what happens when we try to complete the square for an arbitrary equation. So we have some number a squared plus bx plus c is equal to 0. So we take the c, we get rid of it from both sides. So we get ax squared plus bx is equal to negative c. So we want this to be some number squared. So I'm going to say the square root of ax squared plus, we want this to be some number, we want this to be 2 times a and then we need to get back to b. So what I'm going to do is I'm going to say b divided by all the stuff we don't need. So we don't need the 2 and we don't need the square root of a. And then we have b squared. So we need to add this b squared in here somewhere. So I'm going to say b over 2 square root of a squared, and then we also need to get rid of it because we just added it for no reason. B over 2 square root of a squared, and we still have this negative c out there. So here we have the square root of ax squared plus 2 times the square root of ax b over 2 square root of a. I'm just rewriting all this stuff, plus b over 2 square root of a squared. And then I'm going to add this junk over to here. So I'm going to say, just because I'm adding this to both sides, b squared over 4 times a. Because I'm just squaring, this is just that squared. And then we still have the minus c. So this, if you notice, can be put into a perfect square trinomial, because that is the way we designed it. So I can say the square root of a times x plus b over 2 square root of a squared is going to get me b squared over 4a minus c. Then I can take the square root of both sides. I can take the square root of both sides, so that gives me the square root of ax plus b over 2 square root of a. And then since I took the square root, I also need to take the square root of this side. So we have plus or minus the square root of b squared over 4a minus c. Right? And then this could be subtracted over there too. So we have the square root of ax. I'm just going to subtract this b over 2 square root of a is equal to negative b over 2 square root of a plus or minus b squared over 4a minus c. Since this, I'm going to just find a common denominator between these and add these as a fraction. So I'm going to have ax is equal to negative b over 2 square root of a plus or minus the square root of b squared over 4a minus 4ac over 4a, right? Because I just found a common denominator between these, so I multiplied this c by 4a. So we have the square root of ax is equal to negative b over 2 square root of a plus or minus, and then I'm going to write this as just one fraction, so we have the square root of b squared minus 4ac over the square root of 4a. And then if you notice, this is just negative b plus or minus the square root of b squared minus 4ac over, and then this 4, just to save a writing step, this 4a is equal to 2 square root of square root of a, right? Because the 4 can come out as a 2. And so if you notice, 2 squared of a is the same as 2 square root of a. So I can say all this is over 2 square root of a. And then over here, we still have this a times x. So I want to divide both sides by the square root of a. So by the square root of a, as long as it's in the denominator, I'm dividing it. So I can say that x is negative b plus or minus the square root of b squared minus 4ac all over 2 times, and then the square root of a times the square root of a is a. So if you just have a quadrilateral, no, not a quadrilateral, a quadratic function in this form with ax squared plus bx plus c, and if you complete the square generically using just a, b, and c, you end up with negative b plus or minus the square root of b squared minus 4ac over 2a. So you could put, anytime you have it in this form, if you just take your a, b, and c and you shove it into this equation, you will get the values for x.